Hello students, welcome back to Future Foundation. Students, in last class of vectors, we did questions based on dot product. Now in today's class, we will start cross product and we'll discuss its properties and questions related to them. So let's start the class. Cross product. Point 1. For A vector and B vector. Point 1. For A vector and B vector. A cross B is the cross product of A vector and B vector. Point number 2, A cross B is equal to mod of A vector into mod of B vector to sine theta n cap, where theta is the angle between A vector and B vector and n cap is the unit normal vector to the plane of A vector and B vector. Means A cross B is defined as mod A mod B sine theta n cap. Point number 3, mod of A cross B is mod A mod B sine theta, right? Because mod of n cap is 1. So n cap can be written as A vector cross B vector on mod of A vector cross B vector, right? Or it can be written as K times A cross B, where K is nothing but 1 by mod of A cross B, which is a scalar quantity. So n cap is equal to K times or scalar multiple of A cross B. It implies that n cap is parallel to A cross B. It means direction of A cross B is perpendicular to the plane of A and B. Means A cross B is perpendicular to both A vector and B vector, right? So for example, there are two lines in a plane L1 and L2. L1 is defined as R vector is equal to A vector plus mu times C vector, and L2 is defined as R vector is equal to A vector plus lambda times P vector, where A vector denotes the position vector of the point of intersection of L1 and L2 in a space. Say this is A vector. Now if I want the equation of line passing through the intersection of L1 and L2 and also perpendicular to L1 and L2 both, so I can write it as R vector is equal to A vector plus some T times B cross C vector, right? Because B cross C is perpendicular to B and C, right? So this is the required equation of line L. Okay, now example 2, E dot E cross B is 0 as E vector is perpendicular to A cross B. Similarly, I can write B dot A cross B is 0, reason is same. And also If I extend this concept in example 2, which I used uh, to three vectors, say A, B, C, that is E cross B cross C dot A cross B is 0, as A cross B cross C vector is perpendicular to A cross B, right? Now, this is point number 2. Point number 3. Now come to point number 4. Point number 4 is sine theta is equal to mod of A cross B by mod A into mod B, and cos theta is equal to A dot B by mod A into mod B. If I square and add both above, so I will get above, so I will get mod of A cross B square by mod of A square into mod of B square plus A dot B square upon mod of A square into mod of B square is equal to 1, or I will get A cross B square, because mod square or simple square is same. So A cross B square plus A dot B square is equal to mod of A square into mod of B square. Okay, let us take a question. If mod A is equal to 1, mod B is equal to 1, and mod C is equal to 2, find angle between A vector and C vector if A cross C minus B vector is equal to null vector. Okay, so what is asked in the question? Angle between A and C. So what is given to us? A vector cross C vector is equal to B vector, right? Now, as we know, E vector and A vector cos C vector are perpendicular. So angle between them is 90. Now take mod on both sides. So A mod of A cross C is equal to mod of B, and after expanding, this will be mod of A cross C into sine 90, or sine of angle between A vector and A cross C, which is 90, right? ये बन हो जाएगा cos angle is 90, right? Because this is 90. So now what I have, mod of A vector. Mod of A vector is 1. So this is mod of A cross C is equal to 1, right? Because mod of B is also 1. So now mod A mod C into sine of E vector vector cap C vector means angle between A and C is 1 and mod of C is 2 and mod of A is again 1. So sine of theta is equal to 1 by 2 where theta is the angle between A and C. So theta is 1. So theta is sine inverse half which is pi by 6 or 5 pi by 6. Theta can be 5 pi by 6 cos theta lies between 0 and 180 degree. Okay, now let us write some properties of dot product of cross product. Properties of cross product. First property is cross product is not commutative. It is A cross B is not equal to B cross A, but A cross B is equal to minus of B cross A. Means sign will get changed. If you reverse the order, then minus sign will be introduced. Property 2, A cross B plus C is A cross B plus A cross C, right? Means cross product is distributive over addition or subtraction. Third, A cross A is 0 because A cross A is A sine 0 and cap. Sine 0 is 0, so this will become 0. So similarly, I cross I is 0, J cross J is 0 and K cross K is 0, right? Fourth one is I cross J is K. Okay, proof is very simple. I cross J is I J sine theta. Theta is the angle between I and J, and we know the angle is 90 degree. Okay, so IJ and n cap and n cap in this case is K, because n cap is nothing but unit vector, unit normal vector to I and J, and we know orthonormal triad IJK JK. Okay, so mod I mod J is 1, sine 90 is 1, so this is K cap, right? So IJ is K, J cross K is I, and K cross I is J. Okay, so this thing will help you to remember this cycle IJ and K. Okay, now for example, A cross I. A cross I means A is A1 I cap plus A2 J cap plus A3 K cap cross I. I cross I is 0. So J cross I is minus K. So minus A2K plus A3J. Similarly, A cross J is A1K minus A3I, and A cross K is minus A1J plus A to I. Take a question. A cross I dot I plus A cross J dot J plus A cross K dot K is equal to question mark. So A cross I dot I is 0 as A cross I and I vector are perpendicular. So 0, similarly 0 and 0, which will become 0. Now A cross I whole square plus A cross J whole square plus A cross K whole square is equal to question mark. And A cross I whole square is mod A square I square minus A dot I square, which is mod A square minus A1 square, right? Similarly, A cross J whole square is mod A square minus A2 square, and A cross K whole square is mod A square minus A3 square. After adding A cross I square plus A cross J square plus A cross K square is equal to 3 mod A square minus mod A square, which is 2 mod A square. Okay, now let's move to next property. Property number 5. Four properties have been discussed so far. Now property number 5. If A plus B plus C is equal to 0, then A cross B is equal to B cross C is equal to C cross A. Okay, let's see its proof. What is given to us? A plus B plus C is null vector. So if I take cross product both sides with A vector, then what I will get? A cross A is 0, so B cross A plus C cross A is 0. Okay, now B cross A is equal to minus C cross A, which will become A cross C. Okay, now again taking cross product with B vector both sides, then what I'll get? A cross B plus C cross B is 0 because B cross B is 0. So here it will become A cross B is equal to B cross C, right? So in this I can write, in above I can write C cross A is equal to A cross B also, right? So from this and this I can say A cross B is equal to B cross C is equal to C cross A. Okay, and that's the proof completed. Next property number 6. If A cross B is equal to C, B cross C is equal to A, C cross A is equal to B, then first part is A vector is perpendicular to B vector is perpendicular to C vector, and second is mod A is equal to mod B is equal to mod C is equal to 1. Okay, so I have to prove these two parts. Now in first part, if I see, or we will see, then we can understand this in our mind without or we need not to prove it by using pen, as it is given A vector and A vector cross B vector is equal to C vector, and we know if this is A vector and this is B vector and this is C vector, so say A vector, B vector and C vector, A vector cross B vector is perpendicular to A vector cross B vector is perpendicular to A vector and B vector, right? And A cross B is equal to C means A C vector is perpendicular to A vector and B vector, right? Similarly, B vector cross C vector is perpendicular to B vector and C vector, and it is also given that B cross C is A. So again, B vector is perpendicular to A vector and C vector is perpendicular to A vector. So it is understood. No need to give its proof. Now come to second part. Proof of second part. A cross B is equal to C. A cross B is equal to C. So after taking mod both sides, what we will have this thing, or mod A mod B into sine theta, and theta is 90 degree. We have seen in first part. So mod A mod B is equal to mod C, right? Similarly, mod B mod C mod B mod C is equal to mod A. If I divide these two, then what we'll have, mod of A square is equal to mod of C squared, or you can say mod A is equal to mod C, right? Again, taking 3 means mod C mod A it is equal to mod B. Okay, now if I divide this by second, that is mod B mod C mod B mod C, and in right hand side mod A. Mod C cancel out, so this will be mod A square is equal to mod B square, or mod A is equal to mod B, right? So from this and this, mod A is equal to mod B is equal to mod C. One thing I need to prove that these all are equal to 1. So if I put this thing in 1, that is mod A is equal to mod C. So if I put mod A is equal to mod C in 1, so what will I get? Mod A mod C into mod B mod C to mod B is equal to mod C. Simply mod B is equal to 1. Put in this, and so I will get mod A is equal to mod B is equal to mod C is equal to 1. This is the required proof, hence proof. Okay, now let's come to its geometrical interpretation. So write down the heading: geometrical interpretation of dot cross product. So geometrically it represents the area of parallelogram. So write in this mod of A cross B is equal to area of parallelogram having adjacent sides as mod A and mod B. Okay, so let us see its proof. Say this is A B C D, a given parallelogram having adjacent sides mod of A vector and mod of B vector. So D is the height of the parallelogram, which is given by mod B sine theta, where theta is the angle between A vector and B vector, or angle between adjacent sides. So area of parallelogram ABCD is 2 into area of triangle ABD, right? Which can be written as 2 into half. Base is mod A and height is mod B sine theta. Okay, so it will become mod A mod B sine theta, which is mod of A cross B. So from here we can see area of parallelogram ABCD is mod of A cross B. Okay, now write one remark. Okay, what I have seen in this interpretation, that area of parallelogram is mod of A cross B. But in that case, what we have observed, that the area of triangle ABD is nothing but half AB vector cross AD vector, or half mod of AB vector cross AD vector, right? So if I have a triangle ABC having position vectors A vector, B vector and C vector, and area will be mod of delta vector, which is half BC vector cross BA vector, right? BC vector cross BA vector. What I have done in our, that's that is the thing I have written in this remark. So this is half BC is C minus B cross BA is A minus B. So this is C cross A minus C cross B minus B cross A plus B cross B, and B cross B is 0, so this will become minus B cross A can be written as A cross B, minus C cross B can be written as plus का B cross C plus C cross A. Okay, this is mod of delta vector. So this is the area of triangle when we don't have the sides but we have the position vectors of the vertices. Then we can calculate area by using this. Okay. Second remark is area of quadrilateral ABCD. Suppose we have quadrilateral ABCD where AC and BD are its diagonal. So AB, AC, AD. Now, area of quadrilateral ABCD, area of quadrilateral ABCD can be written as the sum of triangle ABC and ACD. So area of triangle ABC plus area of triangle ACD, which is half EB cross AC, right, plus half AC cross AD. Okay, so AB cross AC half common AB cross AC plus AC cross AD. Or if I change the order of AC and AD, then the minus sign will be introduced, minus of AD cross AC. Why I did this thing, you will understand in this step. I have to take AC common, so this thing will be written in this manner: AB vector minus AC AD vector cross AC vector. Okay, and here if I see AB vector and AD vector, so AB vector plus BD vector is equal to AD vector. Same figure. So AB vector minus AD vector is minus BD vector. So here this is minus BD vector cross AC vector. Okay. So this thing will be written as half of AC cross BD, area of quadrilateral, half AC cross BD. Now let us take a question. Question is, if A1, A2, A3 dot En are vertices of a regular polygon with n sides and O is its center, show that summation OAI cross OAI plus 1 from I is equal to 1 to n minus 1 is equal to 1 minus times OA2 cross OA1. Okay, so बच्चे, what I need to prove you can see in the question. So here this A1, A2, A3, A4, no? Dot AN is a polygon of n sides and center is origin. Each side is making an angle 2 pi by n at its center from given, that is summation OAI vector cross OAI plus 1 vector, where I is equal to 1 to n minus 1. If I expand this, it will be written OA1 vector cross OA2 vector plus OA2 vector cross OA3 vector plus plus OA n minus 1 vector cross OA n vector, right? So OA1 cross OA2 is nothing but mod OA1 to mod OA2 sine 2 pi by n to n cap, where n cap is again unit normal vector perpendicular to the plane of A1, A2. Similarly, plus mod OA2 vector plus into mod OA3 vector sine 2 pi by n to n cap plus and so on to OA n minus 1 vector to OA n vector sine 2 pi by n cap. So as polygon is regular, so all sides are equal, I can write these how many terms are there? N minus 1 term, because OA1, if I go from OA1 to n minus 1, I will cover n minus 1 term. So this whole thing can be written as n minus 1 times mod of OA1 vector into OA2 vector sine 2 pi by n into n cap. Okay, so this will become OA1 vector cross OA2 vector, right? And if I change the order, then minus sign will come out, and this will become 1 minus n times OA2 vector cross OA1 vector, which is RHS of proving. So hence proved. So students, let's meet in next class. Till then, bye bye, take care.